All right, so if you look at your homework, did everybody pick up a homework? Pick up a homework. If you look at your homework, you realize it's not super long. If you look at your homework, you realize we're about to do more of the same, which is hopefully reassuring. Hopefully we're not intimidated. We're doing more of the same, only it's going to be a little bit different. We're going to have logs and e's. So I split this up because there's just so many different types of these multivariable differential equations that to be prepared for all of them, let's just take it in steps of 2. The ones we did last class did not involve logs or e's at all. The ones we are about to do will, okay? Now, before we get into like the actual homework problems, as you see, I need to remind you about some exponent properties that we'll be using. It will be advantageous for us to use to simplify certain situations to be able to solve for C. Now, we are used to saying x squared times x cubed is just x to the 5th. But one step in between going straight to x to the 5th is to write x to the 2 plus 3. And yes, that's x to the 5th. But why I show this middle step is because it will help us sometimes to be able to go backwards. Take x to the 2 plus 3 and turn it into x squared times x cubed. So x to the y plus 5, sometimes it will help us if we write it as x to the y times x to the 5th. This versus this, not necessarily different, but watch how I can manipulate this knowing that C is a constant. Using the exponent property rules of addition, we could write this as e to the c times e to the x. And the reason why I write e to the c first is because of what I'm about to do. E to the c, if c is a constant, is just c. And all of a sudden, we have c times e to the x, which sometimes will be in a good spot, in a helpful position when we are solving our differential equations we're about to solve. Other exponent property rules, we can write things as power to a power, which sometimes will help. An example of where that would help is this situation, e to the 1/2 times log x. This does not simplify to be 1/2 times x. Some people think the e and the log cancels and you just have 1/2 x, but that's not correct, because we could write this as e to the log x to the 1/2. And when we do that, we see that we should simplify to be x to the 1/2. Okay, so these are all just like simple exponent simplification things that we will be using. Also, what we'll be using when we're solving these differential equations is our knowledge of the inverses of e to the x and log x, how we can use one to undo the other. If it's just e to the x, and there's not a number in front of it, not a negative in front of it, if it's just e to the x, you can take the log of both sides. Log of e to the x being inverses will undo what the other one does. If you have log of a variable equal to a number and you want to solve for that variable, you would take e to the power. That's how this inverse would work, giving you k equals e to the 4th. Okay? So that is review from Unit 4. What's a little bit new is the fact that we're going to have c's being involved. Whenever we take antiderivatives, we have that plus c. Let's say I had to solve for y. What's very important is to take e to the entire side. And a lot of times when we've been manipulating c, we've said like, oh, 2 times c is just c. If you subtract the number from c, you still have c. But in this situation, we do not say the right side would be e to the 5x plus c. This is wrong, because it's e to the entire right side. The plus c goes in the exponent. And just like I told you, we can use exponent rules, and all of a sudden, this plus c turns into a c times e to the 5x. Okay? Over here, I have y. I want to solve for y. I'll take the log of both sides. What's very important is that this is not log 4x squared, and then on the outside plus c. You have to take the log of the entire side. So that would be wrong. I would make sure by using parentheses, I write log of 4x squared plus c. All right. Some other property reminders. We're not going to use these much, but just in case you see something and you're wondering, like, why do they do that? Log properties are very similar to exponent properties, which is why these properties are what they are. You probably remember these from pre-calculus, maybe even algebra 2. Okay. Now, let's start solving some differential equations where we'd have to use logs and e's. Here we go. Everything's the same as last class. Separating our variables is our first step. Go ahead and separate your variables. Get your y's with dy, move your dx to be with the x's. So I got to move the y, and I got to move the dx. I get 1 over y dy equals 1 over x squared dx. Okay? Now I'm ready to take the antiderivative of both sides. Now this is a great first example to do, because we need to remind ourselves that if you have something to the negative first power, you cannot use the power rule. But if you have something to any other negative power, like a negative second, negative third, any fractional powers, you can. So the antiderivative of x to the negative second, add 1, it's x to the negative first, times the reciprocal, negative 1 over x would be the antiderivative. Don't forget your plus c. Over here, though, power rule doesn't work, but we remember the antiderivative of 1 over y, or 1 over x, is log absolute. Okay, the derivative of log is 1 over. That means the antiderivative of 1 over is log absolute. Okay, so we're here. Now, we want y equals and a function of x. So I will need to solve for y. Just like we talked about and I reminded you about, you are ready to get rid of a log so long as there's nothing in front of it, no negatives, no numbers, by taking e to the power of both sides. But this is where our little manipulations come into play. It would be e to the entire right side. We could rewrite this e to the negative 1 over x plus c as e to the c times e to the negative 1 over x, and then e to the c is just a c. Now, to get rid of this absolute value, we would give the right side a plus or minus. However, I don't want the plus or minus. Because it wouldn't be a function. But it's okay, because when you find your initial condition, or you're finding C using your initial condition, y of -1 is equal to 3, you actually can just disregard the plus or minus. You don't have to pick the correct one. Okay, and this is important. If I'm going to take this and this to find C, I'm going to ignore the plus or minus because of where C is located. If I find C is positive, okay, it's going to be just like positive C. If I find that C is negative, all right, it'll be like baked into that C. So like ignore the plus or minus, plug in the 3 and the -1, and you will find the correct positive or negative C. I get C is equal to 3 over E, giving me my solution, y equals 3 over e, e to the -1 over x. This would give you full credit, free response. This is perfect. But we need to be prepared to make this look a little bit different in case it's a multiple choice problem. Maybe we write this as 3e to the -1 times e to the -1 over x. And then maybe we use our exponent properties that will allow us to add -1 and -1 over x. Usually it's just numbers that we are adding, but if it's x's and numbers, you just add them together. So this is good for free response. You may need to be prepared to turn it into this for a multiple choice. Okay? All right, your turn. Go ahead and give this one a shot. The answer is y equals 5e to the 1/3 x cubed. It's a very simple one to do. We all can do it. Don't forget your plus C's. It's probably the most common mistake made, is not remembering a plus C or just taking the antiderivative incorrectly. We divide by y, we multiply by dx. I don't forget about a plus c. I'll get rid of the log by taking e to the power of both sides. I can rewrite things so that the c is no longer in the power of e. And then I can give a plus or minus to get rid of the absolute value. It is very advantageous to have c here when I plug in 0 and I end up with e to the 0. Remember, ignore the plus or minus. I find C is positive 5. I don't have to worry about positive or negative 5. It's just positive 5. That is how I get my answer. All right. Let's just do a little bit of the next one. Get this one started. We've seen one or two like this on our homework. The key, if you have multiplication, and there's a bunch of terms inside parentheses, don't distribute. Do not distribute. You never want to end up adding or subtracting to separate your variables because it doesn't work like that. So, do not distribute. Instead, divide by 2 minus 3y. Multiply by dx. Okay, we're going to have to remember from 2 classes ago, and we had a couple, 2 classes ago, the antiderivative of 1 over 2 minus 3y. Please discuss with your neighbors. What is the antiderivative of 1 over 2 minus 3y? You can write it as 2 minus 3y to the negative first, which means you need what? Log. But that's not correct. Thank you, Mr. Corey. We need a negative 1/3 because we remember about the chain rule, and now there'd be a negative 3 if I took this derivative. I need the reciprocal of the coefficient of my variable so that that 3 will cancel with that 1/3. Very, very important, which is why we talked about it in lesson 2. Don't forget to take the antiderivative of the right side. I will just go through quickly solving. I'd multiply everything by negative 3. I would take e to the power of both sides. This ends up being e to the negative 3x cubed plus c, which is c e to the c times e to the negative 3x cubed, which ends up being c e to the negative 3x cubed. If you understand why this turns into this, you can skip from here to there. You don't have to show every single step, but you need to understand the progression of this to this to this to that. You can get rid of the absolute value by giving it a plus or minus on the right side, but again, you're going to ignore the plus or minus when you end up finding C. I have the 0.07. Might as well just find C right now. So 2 minus 3 times 7 equals C e to the 0. So it's 2 minus 21, which is negative 19. That's equal to C. So I end up with 2 minus 3y equals negative 19 e to the negative 3x cubed. Subtract 2, divide by negative 3. Probably factor out a negative 1 on the top and bottom and make everything positive, but it doesn't really matter. Okay? Next one. Now we have something with an e. We'll do 2 in a row with e's. We'd have to use the log to solve. So separating variables, I'm multiplying by e to the y here and multiplying by dx. take the antiderivative of both sides. Check with your neighbors. What is the antiderivative of e to the y? It's not the derivative. You don't need a dy dx. The antiderivative of e to the y with respect to y is just e to the y. Now, to solve for y, I need to take the log of both sides. But make sure you take the log of the entire right side. You don't leave a plus c hanging. You plug in 2, 0. 0 equals ln of 8 plus c. Go ahead and everybody solve for c. What do you do about the ln? You got to do e to the power to get rid of the ln. E to the 0 is 1 equals 8 plus c. c equals negative 7. My solution is y equals log of x cubed minus 7. Okay, next one. E to the x plus y. How do I separate x's and y's if they're in an exponent? Discuss with your neighbors. Yes, many of you have already written it down. Excellent. We're going to use our exponent properties to write this as e to the x times e to the y. Okay, don't race ahead because many of you will not get the antiderivative step correct. Divide by e to the y, multiply by dx. So the e to the y ends up in the denominator, 1 over e to the y. Dx next to the e to the x. Everybody's probably going to get the right side correct. Antiderivative of e to the x is e to the x plus c. But most of you will mess up on the left side. Do we think it's log e to the y? It's not. It's not log e to the y. A lot of people think that because it's like y to the first in the denominator. But it's e to a power. Negative e to the negative y is correct. Why, Miss Young? What did you do first? E to the negative y. Yes. Instead of 1 over e to the y, rewrite it as e to the negative y. And now we can go ahead, just take the antiderivative of the outside. Don't forget to multiply by the reciprocal of the coefficient of our variable. So, common mistake is to use log. Don't. Now I want to solve for y. Many of you will think to take the natural log of both sides, right? Not yet. It needs to be just e. So don't do that until the negative is gone. Now we will take the log of both sides. But many of you will think that you can simplify the right side because it's the log of some e's. Don't. Just make sure you take the log of the entire right side and leave it. The left side can simplify because it's just e to a power, but the right side does not. Leave it like this. There's no log property that actually separates addition inside of a logarithm. There's a log property that separates multiplication in a logarithm, but that's not this one. We'd have to leave it like that. Get rid of this negative. Again, all of a sudden, y equals negative log e to the x plus c. We have an initial condition. Negative log 4 equals negative log negative e to the 0 plus c. You can take the opposite of both sides. You can take e to the power of both sides. You can solve for c. So go ahead and do that. Let's find c. You get c is equal to 5. Y is equal to negative log negative e to the x plus 5. Okay? Now, moving into some differential equations that do not have x's and y's that we should not be intimidated by. They try to intimidate you. You see these in free response questions. They have a bunch of words. A landfill at the beginning of 2010 contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste. W is a total amount. W will satisfy the differential equation dw dt equals 1/25 W minus 300. Notice dt with respect to time. Going back to related rates, this is how quickly the amount of solid waste is changing in our landfill. Okay? Change in our solid waste over the change in our time. Right? So how quickly the rate of change of our waste in our landfill. We actually don't even have to worry about that in that interpretation. Because you're just asked to solve the differential equation. Find a formula for the amount of waste W equals. We are going to treat this just like any other differential equation. We are going to separate our variables. We are going to anti-derive both sides. Instead of using y's and x's, we got w's and t's. We want to distribute. Don't distribute. Instead, move the w minus 300, leave the 1/25. Divide by w minus 300. Multiply by dt. Boom. Take the antiderivative of both sides. You can write this as w minus 300 to the negative first. The antiderivative would use a logarithm. The right side, easy. 1/25, but not x, because I'm using t's. Don't forget your plus c. If you have dt, you're going to have t's. If you have dw, you have w's. Nothing fancy, nothing crazy. We're just using different variables. We are now ready to solve for w and to find c. Just like all the others we've done, we'll take e to the power of both sides. We know that we can rewrite this as e to the c times e to the 1/25th t, which turns into c e to the 1/25th t. We can get rid of the plus or minus, or get rid of the absolute value by including a plus or minus, but we will want to remove that plus or minus when we use our initial condition. W of 0 is equal to 1,400. We will get C is 1100. We will add 300 to solve. Okay? So, don't be intimidated, and make sure when you're doing your homework, you're actually doing these free response problems, because you're going to see all like 3 steps. The slope field one, we'll do the last one too. The differential, the tangent line approximation, and then solving the differential equation. Let's finish with this last one, because many of you will feel pretty confident about after the last one solving this, but then you'll make a mistake. Okay? You're probably ready to separate your variables. You have 1 over 100 minus b dB after you multiply both sides by dt. And you feel pretty confident about taking the antiderivative of both sides, but many of you will forget something. You forgot something. Many of you are like, yeah, right? It's just log absolute 100 minus b, because it's 100 minus b to the negative first. And then the right side is 1/5 t plus c. Nope. Close. Super close. But you forgot something. Negative. You forgot the negative, because you have a coefficient of your variable. You need that negative. Everybody forgets it, which is why I will remind you time after time after time. You then move that negative over, and you should have a negative 1/5 t plus c. We're ready to go through the rest of the steps. They end up not being too bad. They're very similar to all the other ones. I'll skip a couple. Of 100 minus b equals c e to the negative 1/5 t. We got 0, 20. 80 equals c e to the 0. C is 80. B would equal 80 e to the negative 1/5 t plus 100. That needs to be a negative 80. You got to make sure you solve for B. Make sure you guys do your homework. Thank you.